Okay, this is an extra video to help with trig notes and different examples with classifying triangles. So first we're going to look at reducing radicals again. We talked about this before. What you want to do is you want to find a perfect square as a factor as the number inside the square root. So example, 4 is a perfect square because 2 times 2, you're multiplying the same number by itself to get that value. So this example we have 320. So the square root of 320. Now a lot of people in class broke this down as factors of the square root of 16 times the square root of 20, which totally works because 16 times 20 is 320. And they were like, 16 is a perfect square and the square root of 16 is 4. That's great. Now your answer is not 4 square roots of 20, and this is why. You need to double check with your square root to make sure there aren't any perfect squares. 20, however, does have a factor that's a perfect square. The square root of 4 times the square root of 5. 4, like we said over here, is a perfect square because of 2 times 2. This breaks down to be 2. So the last step we need to do is those perfect squares, the numbers we get from it, we need to multiply those together. So we get 4 times 2, which is 8. And then finally we need to combine that value with what we have in the square root. So our final answer is going to be 8 square roots 5. So that's just a little extra reminder on reducing radicals. Here's why. Before with the Pythagorean theorem, a squared plus b squared equals c squared, we just had like c squared equals 17.1 or b equals 2.2. Now we're going to leave them in radical form, so we want to get them in simplified radicals. So if we have the triangle where one side is 7, another side is 6, and our hypotenuse is x, whenever we solve for x, we're going to leave it in simplest radical form. So we have 6 squared plus 7 squared equals x squared. 6 squared is 36. 36 plus 49 equals x squared. So we have 85 equals x squared. Take your square root like normal. Now we want to simplify this radical, but if you look through all your perfect squares, none of them are a factor of 85. So your answer is literally just going to be x equals square root of 85. If there was a perfect square that was a factor of 85, then you would pull it out and you would have a number times the square root of another number. So for this problem, your answer is just square root of 85. Okay, triangles. Here's the deal. Largest angle is opposite of the longest side. Smallest angle is opposite of the smallest side, and the middle angle is opposite of the middle length. So problems 2 and 3 are examples of this. So if you have your triangle, and I know this is drawn differently, so Hooligan Lane or whatever is over here. You got MLK Boulevard and Valley Road. So Valley, I think, is 120, MLK is 105, Hooligan is 175. So this problem asks, they want to put the bench at the corner with the largest angle, and it asks for what streets form that angle. Well, Hooligan is the longest side. The largest angle is opposite the longest side. So we want to put our bench between Valley and MLK. Now problem 3 looks at angles. So you're given 58 and 62, and we need to solve for that upper one. So remember, add them together. 180 minus that value, you get 60. Now, I apologize that these letters aren't in the same order, but I'm going to label as T, V, or U, T, and V. So we want to order them from shortest to longest. So our shortest side is across from the smallest angle. Our smallest angle is 58. Across from it is TV, so our first side is TV. Our second angle, that second smallest, or our middle angle, is 60. Across from 60 is UV, so that's our middle length side. And then lastly, 62 is our largest side. Across from it is UT, so UT is our longest side. So I'm sorry if I put the letters in a different order, but that's how you kind of solve that problem. That's pretty much the same as problem 3. Okay, when we if we're given 3 lengths, we want to figure out if it forms a triangle. So here's the deal. For it to form a triangle, 2 sides added together must be larger than the third side. So A plus B must be larger than C. B plus C must be larger than A. And then A plus C must be larger than B. So for B, I will have on here, but then I think for A, I messed up the number, so it's a little different. So if you're given the length 6, 7, and 9, you want to check and make sure 2 of them added together are bigger than the third. So 6 plus 7, you get 13. That's bigger than 9, so far we're good. 7 plus 9, you get, 15, which is bigger than 6, so you're good there. And then 9, oh, that should be 16, my bad. And then 9 plus 6 is 15, which is bigger than 7. So this does form a triangle, because 2 sides added together are larger than the third side. Our second problem is with 5, 10, and 15. So 5 plus 10, that is equal to 15. Our largest side is 15, so this is not a triangle because the 2 sides have to be larger than the third, and it's not, it's the same. Now, here's a little quick start. You only have to add the 2 smallest sides together. If that's larger than the third side, then it's a triangle. Okay, and then lastly, obtuse, acute, or right angles. Here's the rule. Once you check to see if it is a triangle, to determine if it's acute, a squared plus b squared needs to be bigger than c squared. Obtuse is a squared plus b squared is smaller than c squared. And then a right angle is a squared plus b squared is equal to c squared. So that Pythagorean theorem. So we're going to look at problems 6 and 7. 6, we have the values 7, 11, and 13. We want to first check that it is a triangle. 7 plus 11 equals 18. 18 is larger than 13, so it is a triangle. So now we need to do 7 squared plus 11 squared, or a squared plus b squared, which is 49, plus 121, which equals 170. And then you have c squared, which is 13 squared, which is 169. A squared plus b squared is 170. 170 is larger than 169, which is c squared, so we have a q. A squared plus b squared is larger than a squared. So this triangle right here is a q. Now, for our second one thing you want to do with number 7, since we have 7 square roots of 3, check in your calculator to see what the value is, because when you do, you'll see that it's actually about 12.12. That is smaller than 14, so your order should be 7 square roots of 3, 14. So in your calculator, how you want to type b, you'll have 7 squared plus, and then you want to start with parentheses 7 square root, and then in your square root, parentheses 3, close that parentheses squared. That's how you want to type it in for it to give you the right answer. So then you have 49 plus 147, and that equals 196. And then your c squared, 14 squared, equals 196 also. If a squared plus b squared equals c squared, then you have a right triangle. So this triangle would be indeed right. Also, one thing I forgot to do, we need to check and make sure this actually is a triangle. 7 plus 7 square roots of 3, which is about 12.12, equals about 19.12, which is larger than 14. So yes, it is a triangle, and it is right. I hope this helps. Email me if you have any questions. I'll see you next week.